right, let's get right into it. We're going to be looking at a totally different way to think about math. Seriously, this isn't about the old rules you had to memorize. This is all about how our brains are actually built to learn in the first place.
So let's be honest, it's a question we've all asked at some point, right? Maybe you were in a classroom, staring at a problem, or trying to help with homework, and you just hit a wall. That feeling of total frustration, why is that so common when it comes to math?
Well, it turns out it's really not just you. This is a global thing. The latest PISA rankings, which are these huge international student tests, show that math scores have dropped pretty much everywhere. The data is super clear. This isn't about a few kids struggling. It's a crisis in how we teach math.
Okay, so if it's not the students, what's the real problem? Well, neuroscience points to one major culprit, and it's called cognitive overload. Let's unpack what that actually means for your brain when you're trying to learn.
You see, it all comes down to two totally different ways of learning. The traditional way is all about memorizing abstract rules. Just do this, then this. And that puts a huge strain on your brain. But there's another way, one that uses visual proof and hands-on discovery to build a real deep understanding from the ground up. So here is the absolute key. Traditional math tries to cram everything into the prefrontal cortex. Think of this as your brain's little sticky note for short-term memory, and it just gets overloaded. It's kind of like trying to pour a whole gallon of water into a tiny coffee cup. It's going to spill everywhere, right? The information just doesn't stick.
But what if you could just bypass that problem area? This is where this new approach comes in. It's designed to work with your brain's natural wiring, not against it. It's basically a way to rewire the whole learning process.
And here's the secret sauce. Instead of forcing everything into that overloaded memory center, this method uses virtual tools to fire up a different part of the brain entirely, the parietal lobe. This is your brain's headquarters for spatial reasoning, for seeing and doing things. Suddenly you're not just memorizing, you're actually interacting with the ideas. This all leads to something amazing called visual proof. And that's not just some buzzword, it's that aha moment. You know the one I'm talking about. It's when you don't just learn a rule, you see why the rule is true. It creates this deep, unshakable understanding that you just can't get from a textbook. And get this, there's actual brain chemistry at play here. That aha moment feels good for a reason. It literally triggers your brain's reward system, releasing a little bit of dopamine. This creates a positive feeling, a positive connection to math. It stops being this awful chore and starts being kind of fun, like a puzzle you actually want to solve. Now, this doesn't happen by accident. It's a very deliberate, structured process. Let's take a look at the repeatable cycle that makes this whole thing work so well. It's called the 5-step neural loop. You start with hands-on exploration. That's where you get the visual proof. Then you practice it. Then you apply it to real-world problems. Then you master it through fun, gamified play. And finally, you reinforce it with targeted review. See? It's a complete learning cycle. Okay, so the theory sounds great, but what does this visual proof stuff actually look like? Let's check out a couple of real-world examples to see how it makes things click.
Remember being taught to borrow the one in subtraction? It's confusing, right? Such an abstract rule. But look over here on the right. You see what's really going on? A student literally takes a 10 block and physically breaks it into 10 little 1 blocks. It's not borrowing, it's regrouping. It's proof you can see and touch.
And it works for tricky stuff too, like fractions. Instead of just memorizing multiply the tops, multiply the bottoms, students can see it. They take a shape that's 1/2, they overlay a shape that's 1/3, and they can visually see with their own eyes that the part that overlaps is exactly 1/6 of the whole. The concept just clicks. And this scales up. The same basic tools can be used to make abstract algebra make sense. An equation just becomes a balancing scale. If you want to solve for x, you just have to do things to both sides to keep the scale balanced. It builds this beautiful, intuitive bridge from basic math to the more advanced stuff. So the method feels right. It's intuitive, but does it actually work? Well, let's look at the numbers, because this isn't some brand new theory. This is a system that's been tested and fine-tuned for over 20 years. Yeah, this whole approach started way back in 1999 in South Korea. So we're talking about more than 2 decades of data, of refinement, and of proven success in one of the most competitive education systems on the planet. And the results? Get ready for this. After about 2 to 3 years, schools that implemented this system saw their average student math proficiency climb to over 85%. Let that sink in. Over 85%. That's not just a little better, that is a staggering leap forward. And you can see that journey right here on this growth dashboard. Students start out around 35% proficiency, pretty typical, and then they just climb steadily year after year until they hit that 85% plus mastery level. The proof is in the data. So how do they guarantee results like that? It's something called the adaptive mastery loop. If a student takes a quiz and doesn't hit that 85% target, they don't just get a bad grade. No. The system automatically gives them a targeted review, using those visual tools to fix the exact concept they misunderstood. It's about intervention, not punishment. And what's really cool is that this approach empowers everybody. Students get this clear, engaging way to really get it. And teachers, they get a massive toolkit, over 40 virtual tools, and even an editor where they can build their own custom lessons without writing a single line of code. I just love this quote because it nails the whole philosophy. It's not about handing teachers a script and telling them to read it. It's about giving them the tools to be real architects of learning, to design amazing experiences for their students. So let's wrap this up with the big takeaways. Number 1, this neuroscience-based method reduces that cognitive overload by using a different part of the brain. 2, it creates deep, real understanding through visual proof. And 3, and this is the most important part, this isn't just a cool idea. It's a system backed by over 2 decades of hard data and real results. And that kind of leaves us with one final big question. This whole system is built to replace that frustration and anxiety with discovery and confidence. So, what if that fear of math that so many of us grew up with, what if it could actually become a thing of the past?